All right, so in this example, what we're going to be doing is we're going to be determining whether two lines are parallel. Put that a little bit there. If they're going to be parallel, perpendicular, or neither. So let's just go over the criteria for each of these guys. So parallel lines. Okay, so parallel lines are just two lines that don't intersect. So like this, right? If these two lines were to continue indefinitely here, I'll put arrows at the end of them, then these would be parallel. They're going to keep going and going and going. It's kind of like railroad tracks, right? Railroad tracks just keep going and going and going next to each other. They're never going to collide or intersect with one another. Okay, so that's just what a parallel line is. And two non-vertical lines with the same slope are parallel. So if this had a slope, if m was a half, then this must have a slope of 1/2. It has to. If it's anything different, then sooner or later the lines would intersect. So one of the important characteristics of parallel lines is that they have the exact same slope. And also, two non-vertical parallel lines have the same slope. So that's exactly what I just said right now. And the reason why that says non-vertical lines is because by definition, if I have two vertical lines, then they're parallel. That's just by definition. So that's why I'm saying it's two non-vertical. And also the reason why that this definition says non-vertical is because vertical lines don't have any slopes. So you can't say if two non-vertical, if you don't put this in there, then that means you would say that two vertical lines have the same slope. Well, really, they don't have the same slope because they don't have a slope at all. So this is just being very technical right here. Really, check this out. The only thing that you have to know about parallel lines is that they have the same slope. That's the most important thing right here. Okay, so parallel lines have the same slope. All right. Now, what about perpendicular lines? Here's an example of what perpendicular lines look like. Here's a line and here's another line. These two lines are perpendicular, and the reason why that they're perpendicular is because they make a right angle or a 90-degree angle right here. See that right there? Now, what about their slopes? Well, their slopes are what we call negative reciprocals. So they're going to be negative reciprocals. So, for example, if this slope, let's start with this guy. If this slope is a over b, then the negative reciprocal means you flip a over b and get b over a, and then you take the opposite of it, negative. All right? And if you were to multiply perpendicular slope, so if you multiply a over b times negative b over a, check out what happens. The a's cancel, the b's cancel, and we're left with just -1, which is why it says perpendicular lines have slopes that are negative reciprocals, and that is their product is -1. See that right there? So if you multiply the slopes of two perpendicular slopes, then you'll get -1. And they have negative reciprocals. So here's just some examples of negative reciprocals. So say if I had one line, say if line 1 had a slope of 2/3, okay, then the second line, if it was perpendicular to that, would be -3/2. I think that makes sense. So you just flip it and then you do the opposite sign. Say if one of my lines was 1, then the negative reciprocal, so 1 is 1 over 1, right? So if I flip 1 over 1, I get 1, and then the opposite of that is negative. So these two are perpendicular, these two are perpendicular. And if I multiply these, I get -1. If I multiply this, I get -1. So most important thing here, same slope. Most important thing here, negative reciprocal slope. We're going to use that information now to do these two examples down here. All right, so we want to determine, it says the line 15, 9, and 12, -7, and the line 8, -4, and 5, -20. The directions above said determine if the two lines are parallel, perpendicular, or neither. Okay, so if they have the same slope, then they're parallel. If they have negative reciprocal slopes, then they're perpendicular. And if neither of those things happen, then we're done and we just say that it's neither. All right, so I have my first line, L1, and that has one point of 15, 9, and then I have my other point of 12, -7. Okay, so can we go ahead and find the slope between those 2 points? I'm going to do y2 minus y1, so 9 minus -7, and then 15 minus 12. 15 minus 12. Okay, so 9 plus 7 is 16, and then 15 minus 12 is 3, and we can't reduce 16 over 3. Okay? Now let's find the second slope, and that consists of these points. We have the point 8, negative 4, and we have the point 5, negative 20. So let's go ahead and find the slope between those 2 points. Again, I'll just subtract from top, bottom. Negative 4 minus 20. And in the denominator, 8 minus 5. So negative 4 plus 20 is negative 16. And 8 minus 5 is going to give us 3. Oh, wait a minute. This is supposed to be a positive 16. I'm sorry about that. Positive 16. Because that's a 20 is bigger than the negative 4. So 16 thirds, 16 thirds. What does that mean? That means that these lines are parallel. Okay, so they are parallel right here. Good. Let's look at this other example right here. And this time, I give you the equation of both of these guys. And so the way that we're going to do this is that we're going to write each of these in slope-intercept form. So I'm going to solve for y and then solve for y, and let's compare their slopes. So I'm going to go ahead and first subtract 2x from both sides there. Get 5y equals negative 7 minus 2x. I'm going to divide both sides by 5. So y equals negative 7 over 5 minus 2 over 5x. Okay, and I'm just going to highlight the slope. Remember, it's always the coefficient of x. So that's the slope of our first guy right there. All right, I'm going to go do a little dividing line now. And let's try this guy now. Okay, I'm going to solve for y again. So I'm going to subtract 5x from both sides. So I get negative 2y equals 1 minus 5x. Divide both sides by negative 2. And I get y equals negative a half plus 5 over 2x. All right, I'm going to highlight the slope as well. Let's compare the slopes. Negative 2/5, 5 over 2. See, 5's on the bottom, 5's on top. 2's on the top, 2's on the bottom, and they're opposite signs. So it looks like they are negative reciprocals. So that means that these slopes are perpendicular. And those are those two examples.